Hello students, welcome back to our channel Abhyaas IIT Prep. Welcome back to our JEE paper analysis series. So we are going to discuss today about the 21st January evening shift paper. Let's get into the video. So 26th question. So it is from electrostatics and mixing of the gravitation. So see that question. Consider two identical metallic spheres of radius r, each having charge q and mass m. Their centers are having initial separation of 4r distance. What they are saying? They are saying we are having two spheres of radius r. Separation between these two spheres is 4r. So the both spheres are given initial speed of u, small u, towards each other. They are moving towards each other. The minimum value of u so that they can touch each other. They can touch each other. What does that mean? So final velocity is equal to 0. That is the meaning of the sentence. So observe here. From the law of conservation of energy, we can take it as E initial equal to E final. In this case, see here, so kinetic energy initial plus gravitational energy potential plus electrostatic potential must be equal to kinetic energy final plus gravitational potential final plus potential of electrostatic. That is the law of conservation of energy. So if you observe here, we are having two spheres. What is the kinetic energy? So kinetic energy of one sphere is half m u square. So we are having two spheres, that's why 2 times of the half m v square. So what about the gravitational potential? So g m square by 4r. That is the distance between them. So what about the electrostatic potential? K q square by 4r. That is the electrostatic potential. So in this final case, velocity of a final velocity is 0. So what is the gravitational potential? So gravitational potential can be written as gm square by 2r. Sir, why you are writing gm square by 2r? You have to take 4r na. So after collision, after touching each other, they are at this position. The distance of separation between them is 2r. That's why I am taking 2r. So after electrostatic potential, kq square by 2r. So what I have to find? I have to find the u value. I have to find the initial velocity. So if we cancel these two, rearrange the things. So m u square equal to g m square by 4r plus, minus, see here, minus this term g m square by 2r plus k q square by 2r minus k q square by 4. These are the terms. So what we have to find? We have to find the final velocity. Initial velocity u. So if you observe and rearrange the things, you are getting u equal to 1 by 4 mr into k q square minus gm square. If you rearrange the things, you will get this answer. So what is the correct option? So if you observe here, you will get the first option is the correct. So this is the moderative question. So we are going to entering into next question. So next one, see here, the charge stored. This question is from current electricity. So capacitor is included and the diodes are also included. So see here, question number 27. The charge stored by the capacitor C in the given circuit in a steady state. In a steady state. So what is the meaning of steady state? In steady state, so in steady state, capacitor is open circuit. So if you observe clearly, this diode is reverse biased. That's why I am removing that one. So if you rewrite the circuit here, so we are having 2.5 volts here and one resistor, 1 ohm, and this is our open circuit due to capacitor, and we are having one more resistor, 4 ohm. So I want to find the charge stored by the capacitor. What is the charge formula? So charge is nothing but Q equal to CV. C is nothing but potential stored in a capacitor. That is the CV. So we know that one I equal to V by R. What is the R? Total R is nothing but 5. What is the potential? Potential is nothing but 2.5 by 5. So you are having 0.5 amperes of current. If you want to find a capacitor stored potential, what do you have to take? You have to take the I into R. So you have to take the I into R. This is our R. So 0.5 into R, that is 4, you are having 2. So Q equal to CV, that's why C we know that one, 5 into 2, that's why 10 microfarad. So option 2 is the correct answer. So this is the question from the current electricity, which includes the capacitor circuit. So next one, see here, from the current electricity. So I am reading the question. The total length of the potentiometer of a wire AB, this is the wire AB, is 50 centimeters. What is this wire length? Wire length is 50 centimeters. So as shown in figure, if a P is the point where the galvanometer shows 0 reading. What is the meaning of 0 reading? So we know that one, if the galvanometer is showing the 0 reading, that means Wheatstone. This is L1 and L2. If you observe R1 resistors, this is R2. So Wheatstone bridge is balanced. We know that formula. So from Wheatstone bridge, 6 by R1 equal to 4 by R2. So from this one, if you write like this one, so R1 by R2 equal to 3 by 2. This is the equation 1. So we know that one, resistance is directly proportional to length. So R is directly proportional to L. So from this one, you can write like this one, L1 by L2 equal to 3 by 2. So if you want to find L1, 3 by 2 times of L2. So from the question, we know that one, L1 plus L2 equal to 50 centimeters. So I am taking this one, L1 plus L2 equal to 50 centimeters. So this is the take 2, this is 3. So from 2 and 3, I am writing like this one. So 3 by 2 times of L2 plus L2 equal to 50. So 5L2 by 2 equal to 50. So if you find L2 equal to 20 centimeters, So from this equation, you can simply write it as L1 equal to 30 centimeters. L1 equal to 30 centimeters. This is your correct answer. So next question, see here, 29. This question is from alternating current, so LC oscillations. It includes the LC circuit. So observe the question. The capacitor C is the first charged fully with the potential difference of V0. And the disconnected from the battery, it is disconnected from the battery. The charge capacitor is connected across the inductor. This is the LC circuit having inductance L. In t seconds, 25% of initial energy in the capacitor is transferred to inductor. So 25% of charge is transferred to inductor. What does that mean? So it is having 75% of energy in the capacitor. So what we have to find? We have to find the time. So the value of time is. So from LC circuit, you can write like this one. A charge after time t equal to Q naught cos omega t. So we know that one final energy can be written as Q square by 2C. So if you substitute here Q value, so Q naught square cos omega t by 2C. So Q naught square by 2C can be written as initial energy U naught. You can write it as initial energy U naught cos omega t. They have given in the problem, what they have given? The final energy is equal to 75% of initial energy. 75% of initial energy. So see here, 3/4 of initial energy. So if you take these two equations, so you will get U naught cos omega t equal to 3/4 of U naught. So U naught get cancelled. So we are having one square here, just forgot. So cos square omega t. So if you write cos omega t or √3/2. So we know that one. At what angle we are getting √3/2? At 60 degrees. So pi/6 must be equal to omega t. So what I need? I need a t. So t can be written as a pi/6 omega. So from the LC circuit we know that one omega equal to since omega equal to 1/√LC. So from this one you can write it as a pi into √LC/6. This is our answer. So what is the option? So option 2 is the answer, correct answer. So we are going to next question. What is that one? So this is the question from the KTG, kinetic theory of gases. This is very easy question. If you know the RMS value of velocity, you can simply solve this problem. So see here question number 30. So the RMS speed of oxygen molecule at 47 degrees centigrade is equal to that of energy molecule kept at dash degree centigrade. What do you have to find? Hydrogen particle temperature you have to find. So see here, what is the condition? So Vrms of O2 is equal to Vrms of H2. Vrms of H2. So they have given what is the oxygen temperature. So temperature of O2, if you observe here, temperature of O2 equal to 47 degrees. We have to convert it into, we should convert that into kelvins, 273. So you will get a 320 Kelvin. What is the temperature? What is the temperature of O2? So that is the 320 Kelvin. So we know that one formula. What is the formula? 3R TO2 by MO2. 3R temperature of H2 by mass of the H2. So if you observe the question, the mass of oxygen molecule by mass of the hydrogen molecule, they have given the masses also. Masses of hydrogen molecule and mass of oxygen molecule they have given. So what do you need to find? What you have to find? You have to find the temperature of the hydrogen. So if we cancel these two, what you are remaining with so temperature of H2 molecule is equal to mass of H2 by into temperature of O2 by MO2. If you substitute the values, you will get the answer. So what is the answer? Mass of H2. Mass of the H2 is nothing but 2, temperature of 320 by 32. So what you are getting? 20 you are getting. So 20 Kelvin. If you convert that 20 Kelvin into degree centigrade, you are having the value minus 253 degree centigrade. So next one, see here. So this question is from rotational motion. This question is from rotational motion. This is very simple question which includes the angular momentum. So observe the question. Two cars A and B, each of mass is having 10 cube kg, are moving in parallel tracks separated by a distance of 10 meter. So two cars are there. So assume this is one car and this is one car. These two cars are separated by distance 10 meter. 10 meter. So in the same direction with speeds 72 km per hour and 36 km per hour. So the magnitude of angular momentum of car A with respect to car B. So angular momentum, we know that formula L equal to mvr. R is nothing but a perpendicular distance, velocity of the B. What is the velocity of B? So velocity of the B vehicle, B car is nothing but 36 times 1 by 18. You are getting 10 meter per second. 10 meter per second. Okay, so see here. So mass is nothing but 10 to the power of 3 and velocity is nothing but 10 and perpendicular distance also 10. So what is the final answer? 10 to the power 5. 10 to the power 5 joule second. So option 2 is the correct answer. I hope you are understanding the question analysis. So next one, see here. This is not very bit difficult as compared to previous one. So observe very carefully. This is from rotational motion. This is from the chapter rotational motion and it is having some pulley problem. It is mixing of rotational motion and pulley concept. See here. The pulley shown in figure is made using a thin rim and two rods of the length equal to the diameter of the rim. So the rim and each rod have mass m. Two blocks of mass m and small m are attached to the ends of the light string passing over the pulley. So if you observe here, we are having two rods. This is one rod and this is another rod. So the pulley, the rim is rotating at the center of the rods. This is our rim. Assume that is our rim. So what they are asking? So the magnitude of acceleration experienced by the blocks. Magnitude of acceleration. So see here, this block is going down. This block is going downward. So at a downward, the block is acting by magnetic field mg, and the acceleration is downward. Acceleration is downward, we know that one. And a tension T1, take it as a tension T1. And in second block, we are having mg and tension 2, and the acceleration is having upside. Along the acceleration direction, we are having more force. So mg is having more force. So observe here, I am writing free body diagram of capital M. Free body diagram of capital M. So I am writing here, see, mg minus T1 equal to capital M A, acceleration. From this one, you can write like this one, T1 equal to mg minus ma. Take it as equation 1. Similarly, write for this second one. So T2, because acceleration is acting upward, that's why tension is more. Tension force is more as compared to gravitational force. So mg ma, that equal to, if you find this T2, so T2 can be written as mg plus ma, equation 2. So if you observe, the free body diagrams of this system is over, blocks is over. So what we are having? We are having one more system. What is that one? A rim and rods. Two rods are there, one rim is there. So it is acting one force, that is the torque. So it is acting torque force. So torque is nothing but, you can simply say this one. In this case, we can write like this one, T2 minus T1 into R. R is nothing but radius of the rim. So torque tau equal to, we know that from rotational motion, I alpha, angular acceleration. So I can be written as, alpha can be written as A by R. So this is our one more equation 3. So in this case, we have to find the moment of inertia of the rim and rods. What is the moment of inertia? I equal to, see here, I equal to moment of inertia of a rim plus a moment of inertia of two rods. We know that one. So rod is at a midpoint, or we know that one, rim or circular ring. So mr square plus 2 times of the mr square by 3. So if you find out 5 mr square by 3, this is our moment of inertia of the entire system. So substitute the values. If you substitute moment of inertia, see here, T2, I am writing T2, so mg plus ma, I am writing T1 minus mg plus ma, that equal to I. What is I? 5 mr square. What is I? 5 mr square. So 5 mr square by 3 into a by r R, and you have to multiply with another R. What do you have to find? You have to simply find the acceleration. If you cancel, you can cancel. R will get cancelled. If you find the acceleration A equal to, we are getting capital M minus small m into G by small m plus 8 by 3 times of the capital M. After rearranging the things, you will get this acceleration. So option 3 is the correct answer. Option 3 is the correct answer. So next one, see here. The kinetic energy of the simple harmonic oscillator is oscillating with angular frequency. They have given angular frequency omega 176 radian per second. The frequency of the simple harmonic oscillator. So we know that one simple harmonic oscillator is the half of the frequency. Frequency of the simple harmonic oscillator is half of the frequency. So you have to find the simply frequency you have to find. So how to find frequency? Frequency formula, we know that one. So omega by 2 pi. They have given omega and they have given pi. So omega equal to 176 by 22 into 7. So you are cancelling with 4 times. So this is 28. So you are having one more answer 28 in this option 2. So if you mark this one, you will get a negative mark. So what is the basic formula for a frequency of simple harmonic oscillator? F by 2. So F by 2 is nothing but 14. This is the correct answer. If you mark this 28, you will get a wrong answer. So next one, see here. So from the wave optics, a simple, very simple statement based question. So see here, what is the statement 1? In YDSA, angle double slit experiment, the angular separation of the fringe will be increased. The screen is moving away from the plane of the slits. So we know that one double slit experiment, this is the slit distance and this is the screen and this is the distance between them. Okay, so what he is saying, if the screen is moving away from the slits, it will increase the angular separation. So next statement, what is that statement? The YDSA experiment, in YDSA experiment, the angular separation of fringe will increase. The monochromatic source is separated by or replaced by another monochromatic source of the higher wavelength. So what you have to take? So you should know the formula of the angular separation. What is the formula for the angular separation? So angular separation is nothing but lambda by d, small d. Small d is nothing but the distance between the two slits. Lambda is nothing but wavelength. So what he is saying, if we increase the wavelength, the angular separation is increasing. So statement 2 is correct and statement 1 is wrong. What is the correct option? So you are getting option 3 is the right. Option 3 is the right. Let's get into the next question. A battery with EMF. It is the question from the current electricity. So this is the maximum power transfer theorem. Very easy question. If you know you can simply mark the answer. If you don't know see here. So a battery with the EMF E and the internal resistance R is connected across the resistor R. The power consumption in R will be maximum. Okay, see here. So we are having one resistance R and potential EMF E and internal resistance smaller. What they are asking? Condition for the maximum power. R equal to 2R, R equal to R by 2, R equal to root 2R, R equal to R. What is the condition? Please say in comments. If you know the answer, please say in comments option A, B, C or D. So see here. So we know that formula, current I equal to E by R plus R, and power formula, simple formula. What is the power formula? So I square, so power equal to I square into resistance, I square into resistance, current square into resistance. If you see here, E square by R plus R whole square into R. So what you have to take? You have to simply substitute R equal to 2R, R equal to R by 2. So you have to substitute the values, you will get the correct answer. Or if you study this theorem, what is that theorem?